Hello. So in this video, I'm just going to be looking at an introduction to limits, and we'll be using these then when we're trying to differentiate things from first principles. So say if you consider this set of numbers here, so we've got a half, a quarter, which is a half of a half, an eighth, which is a half of a quarter. So we're getting progressively smaller every time. If we were going to start adding these up together, say if we took the first two numbers, we added the two of them up, we're going to get 3/4. Then if we kept going along here and we added up the first three of them, we're going to end up getting 7/8. And if you kept going along and you tried to add up, say if you went through all numbers together, you added up all of these, you're going to end up getting 63 over 64. And you can keep going on like this. Like you could double this to 100 and 128, 1 over 128. And then if you add them all up, you'll get onto 127 over 128. And you can see that you're getting really, really close to a number. You're getting really, really, really close to 1. And as you continue on to this, you're going to get closer and closer to 1. But you're never actually going to get to 1 because these fractions are getting progressively smaller. So what we're going to say is the limit of this set of numbers added up together, if you just continue on here, is going to be 1. It's never going to reach it, but the limit of it is 1. So I'll give you an example of that now in an equation. So consider this function here. F of x is equal to x squared minus 9 over x minus 3. Now, if you want to get any of the y values or the f of x values, you simply just plug numbers in there. So you could put 2 in there and you get 2 squared minus 9 over 2 minus 3. That would give you a point on it, and you could continue to plot points. But we're going to arrive at a problem here. If we go to this one and we try to actually plug in 3. So if you put in 3, you're going to see that you're going to get 9 minus 9. And then you're going to get 3 minus 3. And you're going to end up something like this, that's 0 over 0. So the problem on a graph, what this is going to look like. So curves anything that you've been used to so far. Now this isn't a curve, but I'll give you an example of a curve one. Normally curves are drawn left to right like that, and they could move like this, or you could have one like a parabola. But sometimes there'll be an actual break in them. So there might be a little, there might be a part of that graph that's missing. So you might get a point, like in this case, where it's actually undefined. Or else you might end up getting a case where a curve comes up like, so you could get one moving like this, and then it's going to come along and then suddenly move like that. So you're going to get a break in your curve. So if you ever get a break in your curve, it means it's discontinuous. A continuous curve is one that you could just draw left to right without any breaks whatsoever. So if you took this example here and we wanted to find the limit of it. So what if we were to go and find something that gets really, really, really close to 3 but never actually meets it? So I'll give you an example of that. Say if instead of going to 3, we picked something smaller. So we can't put 3 because there's going to be a 0 here on the bottom. But if we picked something really, really close to 3, like 2. So we could put f of 2 is equal to, and then we'll just put it into this equation up on the top. So we'll get 2 squared minus 9, and then 2 minus 3. And that'll end up giving us 4 minus 9, which is minus 5, and then 2 minus 3 is minus 1. So we're going to end up getting 5 in this case. Now let's just pick something that's a little bit closer to 3. So like if we keep going closer and closer to it, so we'll try 2.5. And I'll do this out really quickly. So the answer, if you sub 2.5 into that, you're going to end up getting this. So if you do this out, you're going to end up getting 5.5. Now let's keep going closer to it. So we'll try f of, and we'll go really, really close to 3 this time. So we'll try 2.9. And if you do 2.9 out, you'll get 5.9. And let's go even closer still. So we'll just take one final one. I think you might see where these go. We're going 5, 5.5, 5.9. And if we try 2. F of 2 point, and we'll go really, really close to 3 this time, 2.9. 9. So very close to, but not getting exactly there. We'll end up getting 5.999. So you can see that this is approaching. We're going from 5 to 5.5 to 5.9 to 5.999. So you can see that this is getting really close to 6. Like in the example where we were looking at the fractions adding up and they were equal to 1. So now we'll just have a look through a couple of examples of where we can find limits and how we can use tricks to actually find limits without having to sub in all these numbers. So here's a couple of examples we're going to work through. So the first one, we're just going to write it out here. So if you look at this function here, there's not going to be any problem with approaching 0, because if you were to put 0 into this, it's not going to end up with this thing that we called an indeterminate. So if you end up getting something like this, it's an indeterminate. And that means there's some sort of a discontinuity in the graph, and we need to use some methods to find what that limit is. But in this case, there's actually, you could just sub in, you could put in f of 0 and it will work. So in this case, the limit of this is simple. It's just go inside and replace the x with the 0, with anywhere there's an x, just replace it with a 0. So come across here and you get 3 times 0 plus 5. So the limit of that, the thing that it approaches, if you get really close, is 2 over 5. So try the next one, and this is actually from the example I looked at earlier on with you. So we can see in this example here, we'll try subbing in 3 first and just see it does it work, because that's always our best option. So we'll put 3 squared minus 9 over 3 minus 3, and you can see if you do all that out, you're going to get 0 over 0, which is your indeterminate. So we need to use some other method to find this. So if you look at the two of these, we can actually turn that into x squared minus 3 squared over x minus 3. Now we know we can factorize this one then, and we need to leave in our limit signs here as well. Lim x approaches 3, so we haven't finished with this yet. So we're going to say x minus 3, that'll actually become, is equal to limit x approaches to 3, and then we can change that top fraction to x minus 3 and x plus 3. So that's just the case where if you've got a squared, and sorry I left out my symbol there, it's important. If you've got a square minus another square, you can put into the brackets here. So if you had a squared minus b squared, you could have a, you can factorize that into a minus b and to a plus b here. So you go over, and then down in the bottom, you're going to see you're going to have x minus 3. Now, we can see that the two of these ones are going to cancel each other out. So all you do is you just cross that out, and we're going to be left with the limit of x plus 3. So the limit of x tends towards 3 of x plus 3. Now in this case, you can see that you can actually sub it, you can just sub 3 straight into that. So if you put in 3 in there, you're going to get 3 plus 3. And if you remember for our example earlier on, where we actually where we kept putting in 2.5, 2.5, 2.9, 2.999, we got closer and closer. That is the thing that we were approaching. So we were approaching 6. So by using this method, we can find it without having to sub in them individual values. So for this one, first thing we can do, it's the limit of x approaches minus 5 of the function x squared minus 25 over x plus 5. So we'll try first of all just subbing in minus 5 into that. So if we sub minus 5 directly into this, we can see we'll get minus 5 squared minus 25. So that's going to end up giving us minus 5. So that'll be 25 minus 25. So it's going to give us 0 over 0 when we work all that out. 25 minus 25 is 0, and 5 minus 5 is 0. So this is our indeterminate. So what we're going to need to do here is we're going to need to use some other method to find the limit of that. So we'll go back down to our original sum. We'll write it down here. So for this, we're going to use a similar method to what we used for the last one. So we can actually turn this 25 into a 5 squared. So x squared minus 5 squared. And you might be able to see where we're going to go with this, x plus 5. So we can factorize, and I forgot to actually put in, and this is important, that limit sign doesn't actually disappear. So we need to write that down every line that we're doing, limit, because we haven't applied that limit just yet. So we've limited x approaches minus 5. So that is going to equal to, and we're just going to factorize that out. And again, we need to write it down, x approaches minus 5, x minus 5, so squared minus another square, multiplied by x plus 5. And this is going to give us x plus 5 stays at the bottom, and you can see that these two cancel each other out, and we're left with, we'll do it down on this line, so I'll actually move it down here. So we're going to be left with limit of x approaches minus 5 of x minus 5, and now we can actually put this into it. So we're going to get minus 5 minus 5. So we're going to end up can directly substitute it in there, minus 5, and we're going to get minus 10. So for this next example, we're going to get the limit of x approaches minus 3 of the function x plus 3 over x squared minus x minus 12. So the first thing we should always try first is just to try and substitute it in. So we're going to put minus 3 directly into that. So when we put that in, we get minus 3 plus 3, and at the top that's going to give us a 0. And then at the bottom we're going to get minus 3 squared is going to give us 9. And minus and a minus 3 gives us a plus 3. And then minus 12. And this is going to give us our indeterminate, which is 0 over 0. So that means we need to use another method to do this. So the first one we can try here is factorizing. So write out our problem again. So for this one, what we'll do is we'll try and factorize the bottom of it and see can we cancel anything out. So we're going to say limit and of x approaches minus 3 of x plus 3, leave that as it is, and then we'll just see can we factorize the bottom of it. So we're going to look out here. So the first one, we're going to have two sides here, and then we're going to have an x at the front because we've got a denominator of 1 there. And then we're going to look at what numbers multiply to make minus 12. So let's think about different ones. We'll write it down. We could have, and then we want them numbers to add up to be minus 1. So the things that could multiply together to be minus 12 would be, let's see, minus 2. It'll always have to be a minus by a plus, by 6. Would that work? Could you have 6 minus 2? No, that would give you 4. 2 might. If you change around, say 2 minus 6, that would give you minus 4. Neither of us gives us minus 1 there. So let's look at another set of factors. That doesn't work. 4 by 3. Is there any way you could combine a minus and a plus with a 4 by 3 to get a minus 1 in the middle, which is the one we need here? So yeah, there is. If you did 3 minus 4 plus 3 minus 4, you would end up getting minus 1, and then plus 3 minus 4 will multiply together to get 12. So what you're going to end up getting is x minus 4 and then x plus 3, and you can see that that's going to allow us to cancel this one out and this one out. So we're still left with our limit. So our next stage, we still need to put in our limit sign because we haven't finished up here yet. Limit x tends towards minus 3, and we're going to get 1 at the top, and that cancels out, and then at the bottom we're going to get x minus 4. So you can see that this particular limit then is going to be 10 towards, we just put minus 3 in there, minus 3 minus 4, and we're going to get minus 1 over 7. So now we're going to start looking at limits that approach infinity. So I'm going to give you something that will end up, I'll just give you an example here first of all. Say if you looked at x squared, and if I was going to keep increasing x, so if I went from 1 to 2 to 3, and I kept increasing it forever, what would happen to y? Would it stop at a number, or would it go on forever? Well, you can see in this particular example that if you stopped, if you kept going on with this, well, y will keep rising up and up and up. So you can actually find that by directly substituting it in. There's no, the limit of that will simply be if you put infinity into that and then square it, you're just going to get infinity because it's the largest number you can possibly get. But let's look at an example of something where that won't happen, where it might actually tend to number. So if you had a graph like this, say if you had a graph that started off, went up and up and up and up, but then petered off and came closer and closer and closer and closer to being horizontal. So if you wanted to say that it got closer and closer, say if I drew a line like this, I'll draw it in yellow. Imagine this line is coming across. Imagine if that red line was coming closer and closer to that yellow line. So it's just getting a bit closer every time as far as you move out, and it keeps going up, but it never actually reaches it. That line would be, what would you consider its limit? So I'll show you what that would look like in just an equation form. Not that particular curve, but I'm just showing you what a curve that does that would look like. So say if you had something like this, you had 1 over x. So we'll take the limit as x tends to infinity of 1 over x. Now let's just think about what happens when x gets larger and larger and larger. Let's just think about fractions, right? I'll just write them down here. So if you get here 1 over 1 to start off with, is just going to give you 1. Well, let's just increase that. 1 over 2. Well, a half is smaller than 1 over 1, so you're just going to get you'll get a half. You'll get 0.5. So let's keep going. If you went down, let's increase that to something really high. Let's increase it to 1 over, let me see, 1 over 200. You're going to get 0.02. So you can see that this number is actually getting smaller and smaller and smaller. Let's make it even bigger. Let's make something massively big. And remember that we're going towards a number that's infinitely large. So if we go really, really, really big, we'll put 1 over 99999. So we're going to keep increasing this number for x. So in this case, we're going to get 0.000, so 5 zeros after it, and then a 1 reoccurring after this. So you can see that this is going from 1 to 0.5 to 0.02. So if you're to guess what this is going to go to, well, basically, if this number gets larger and larger and larger, the number here is going to get smaller and smaller and smaller. So this one is going to tend towards 0. So try an example just where we're going to work that out. So our first example, we're going to look at the limit of x approaches infinity of 4 over 3x. So just like our example of 1 over x, we can actually sub infinity straight into that. So if you go 4 over 3 times infinity. So if you think about 3 times the largest number there possibly is still going to have to be infinity. So we've got 4 over an infinitely large number. It doesn't really matter what this is. So we're going to end up just getting 0. So the limit of that is going to be 0. So we'll look at f. Now f is going to require a different tactic to solve it. So if you try to substitute infinity directly into this, so you put infinity squared, which it still has to be infinity, plus 4 won't matter because it's such a big number. We're going to end up getting infinity over, and same thing at the bottom. If we put infinity into this, we're going to get infinity minus 4 times infinity, which isn't something that we can possibly calculate. So it's going to give us something that's undetermined that we can't really solve here. So we could just say that's infinity on the bottom as well. It's not possible to do it. So we need to use some other method to solve this thing. So what we're going to do here is we're going to, and it's always going to be the method when you want to solve x is equal to infinity and you've got powers, you're going to pick the highest power and you're going to divide everything by them. So we'll just write that out. So we're going to get x squared plus 4. I'm just going to put a fraction there to show what I'm going to divide it by, and we'll leave our overall fraction here at the bottom. And then we're going to get 3x squared minus 4x. And what we're going to do is we're going to divide each of these individual things by its highest power. So you can see the highest power here is x squared. So you just go x squared, 4 over x squared is here. And then you just divide x squared into this, and then x squared into this. So let's just work that one out. And just, again, forgetting to just put in my limit sign at the start. So if we divide them all, we're going to get x squared into x squared is going to give us 1. Do our fraction line in the middle, we're going to get 1 plus 4 over x squared. And then x squared into x squared is just going to give us 1, so we're going to get 3 minus, and then x squared, we can only put one x into this, so we're going to end up, these two will this will cancel out with this, and we'll be left with an x in the bottom, so you're going to get minus 4 over x. And again, just put in my limit signs there. So what we can do is just sub infinity into this, and you'll just see how it'll work out. So we'll end up getting 1, we don't sub anything into that, plus 4 times infinity squared is just going to be infinity. 3 minus 4 over infinity again. So what's happened to the two of these ones is these are both going to turn to 0, just like this turned to 0 up here. So what you're going to be left with 1 over 3. So that means that you get something that it's going to go right up really close, but it's never actually, it's going to really close to, but it's never going to reach 1.3 on the y line. So for this one, we're going to use the same method again. What we need to do is divide by the highest power. So just to explain that, if you had an n, so this time we're picking n instead of x. It's the same thing, except we're just using a different letter first of all. If this was n to the power of 4, n to the power of 6, if whatever the highest power is, that's the one we need to divide everything by. But in this, it's n squared, so that's what we're going to divide everything by. So just do that out now. So what you're going to have is you're going to have 2n squared divided by n squared, and then everything else you see, they're all divided by n squared inside it. So we'll just value them out. Remember, we still have to put in our limit. We haven't put it in yet. N tends to infinity. And then we'll just tidy this up here. So we're going to get n squared into n. That's going to give us just 2. Minus, and then this is going to cancel, but we'll be left at an n on the bottom. So we're going to get minus 3 over n plus 2 over n squared. And then below that, we're going to get the two of these cancel each other out. We get 6 plus, and then we're going to get plus 5 over n, because we're going to get our one of our powers will cross out. We can divide n into this, goes once, n into this goes once, and we're left with an n over minus 6 over n squared. So now in this case, all we have to do is we just need to sub everything into that. So we do have our fraction here, and we're going to get 2 minus, now 3 over infinity is just going to give us 0. 2 over infinity is going to give us 0. So we're left with 0 plus 0 here. Then we're going to be left with 6. Again, this is going to become 0 and this is going to become 0. So we're just going to get plus 0 minus 0. And we'll be left with 2 over 6, which we can just break down further. If we divide top and bottom by 2, we're going to get 1 over 3. And that's the limit as n approaches infinity there. So that's my video on limits and how to calculate them. So thanks very much for watching.